Concepts related to atmospheric development. The atmosphere as part of the crust. To the Earth scientist, the crust includes not only the top layer of solid material soil and rocks to a depth of 6 to 70 km to 44 miles, separated from the underlying mantle by differences in density and by susceptibility to superficial geologic processes, but also the hydrosphere, oceans, surface waters on land, and groundwater beneath the land surface and the atmosphere. Interactions among these solid, liquid, and gaseous portions of the crust are so frequent and thorough that considering them separately introduces more complexities and it eliminates. As a result, a description of the history of the atmosphere must concern itself with all volatile components of the crust, materials, volatile compounds, as well as elements important in present and past atmospheres, or in interactions between the atmosphere, biosphere, and other portions of the crust include the following. Present major components: molecular nitrogen N2N, molecular oxygen O2, noble gases helium He, neon Ni, argon R, krypton Kr, and xenon Z. Abundant variable components: water vapor H2O and carbon dioxide CO2. Other components: molecular hydrogen H2, methane CH4, carbon monoxide CO, ammonia NH3, nitrous oxide N2O, nitrogen dioxide NO2, hydrogen sulfide H2S, dimethyl sulfide CH3 sulfur dioxide SO2, and hydrogen chloride HCl. Some elements appear in multiple form, for example, carbon as carbon dioxide, methane, or dimethyl sulfide. It is useful to consider the occurrence of the elements before focusing on the more specific aspects of atmospheric chemistry, the forms in which the elements are present. One can speak of Earth's inventory of volatiles, recognizing that the components of the inventory may be reorganized from time to time, but also that it is always composed primarily of the compounds of hydrogen, carbon, nitrogen, and oxygen, along with the noble gases. Processes. A process that delivers a gas to the atmosphere is termed a source for the gas. Depending on the question under consideration, it can make sense to speak in terms of either an ultimate source of process that delivered a component of the volatile inventory to Earth, or an immediate source of process that sustains the abundance of a component of the present atmosphere. Any process that removes gas either chemically, as in the consumption of oxygen during the process of combustion, or physically, as in the loss of hydrogen to space at the top of the atmosphere, is called a sink.